Okay. So, some kids asked me if I'd stay a little while after school today. I am, but don't feel like you have to go to that because I feel like, at this point, I'll be here a little after school. If you have questions, things that are bugging you, I'll just sit around and answer questions if anyone needs anything. But really, the big thing tonight is you want to eat and get sleep and relax. Um, if you're looking for something just to make you feel better, like an overview of the course, you can always go to my e-board. Sorry. Yeah. If you go to my e-board in the middle, like, well, there are a couple things. Like, if you scroll down, you see this guy? This is just a PowerPoint version of the if when you see, then you should know to do this. So it makes it a little bit more fun. Like, if you go to it, if you click on it and click on the link, um, you'll see something like this, find where the tangent line to the function is horizontal. What you got to do to find out where a tangent line is horizontal? Derivative and what? Set it equal to 0. Yeah. So, like, if you just want to go through some concepts, kind of relax with your feet up, that might be a good way to go. Ooh, how would you? Well, I don't want to get into this, but this is no, right? This is helpful. So you still have to get the derivative, but then what? Yeah, it's undefined, so that means what? The denominator 0. That kind of thing. So this is like these are like this. It's pretty much the same wording as I gave you on that sheet. It's just it's in that fun flashcard format. All right, I can't do this all the time. If you want to find the minimum of anything, what do? To find the minimum of anything, so what equal to 0? The derivative of it equal to 0. So you'd have to find the derivative of it if it's a closed interval. Yeah. Yeah. So you'd have to get the derivative of acceleration. It's called the jerk. Yeah, anytime you want to show you have a max or a min, instead of doing a first derivative test where you make the sign chart, if you know the derivative there is 0, and you plug it into the second derivative and it's negative, it's max. Yes, second derivative determines concavity. It's nice. So that's one thing. So that's a fun thing. And then, how do I get out of this? You can't. Oh my gosh. Yeah, yeah. And then another thing on my e-board, if you know, guys, if you take a look at this over here, there are, kids, all the free response questions from 1999 to 2015 are right here on my e-board with the solutions. Okay? Yeah, and then even before that, there's no reason to go back. So if you would rather just go with something like this, I already opened it. What did I do with it? There it is. If you go there and you scroll down, you can just look at different AP exams. Just go through a couple years. You can look at the questions, and then next to it, you can click on the answers, and you can just kind of glance through them. Like we've done these already. So anyway, that's a lot of fun. Yeah, I think we just go over some of those basics. Now today I wanted to make sure you guys have your formulas down, and I was also asked to go over like the ln of x and e to the x, those kind of things, and a to the u and those kind. So we'll do some of that. But you guys should feel good. You should feel good about yourselves. I mean, if you've been doing all the work and you guys have been great, I think you'll be fine. I know it's scary. Yeah. Hmm. Okay. Okay. Tell her. Average rate versus average value. Average rate it means ratio. Okay. Oh, these are both kind of ratios, but it's a ratio of change because it's the change in y over the change in x. So the slope formula is the average rate of change. It's the ratio of the change in y over the change in x. The average value is 1 over b minus a times the definite integral. And they ask you for the average velocity. Yeah. If they give you a function to determine the number of soda cans that you can collect in a day, and they ask you for the average number of soda cans that you can collect in a day, you use the one with the integral. But if they ask you for the average rate that you collected soda cans during the day, then it's the other one. So you have to look at what they called the function that they gave you, and see if they're asking for the average value of that or the average rate of change of that. Okay, so I thought I was wondering how fast you guys would be at filling out these formulas, because I think you'd be pretty good. No? You got up to 10? And then you got to flip it over, because I got the integration. So these are all the differentiation formulas. Did you do? Oh, she went the wrong way down that street. All right, take a second, see what you remember. Oh, I think I messed one up because on one of them I wrote the same thing twice. I think it's on the second page. This one should be signed. Yeah, I think I wrote cosine twice. This one should be signed. When you get to the next page, you'll see it. It's just the opposite of the inverse sine derivative. It never comes up. I just thought it would be fun. Taking a test. It's a lit test. Woohoo! Yeah. Mhm. Like the derivative of like inverse cosecant is just the opposite, -1 times the derivative of inverse secant. Yeah, but the cosecant's with the inverse cosecant's one with the negative. Well, like the inverse cotan has a negative, inverse cosine has a negative, but otherwise they're just like the other, like inverse cosine. Yeah, just they all have the negative in front, and those really don't ever show up. So if you don't know that, don't let that happen to you. Yeah, k is a constant. Finish the derivatives yet? Yeah. Let's see how many you got right or wrong. All right, so I know that we had. This is good, Doug. You get to see what it is you mess it up. So derivative of constant 0. So number 2, the derivative of a constant to some function, it comes with the 3 parts. It's a to the u. You just have like 5 to the 3x. ln of a, that means the ln of the base, like the ln of 5. And then times u prime, the derivative of the exponent. I hope you're getting the e to the u right. E to the u times u prime. Power rule. If you can't read my writing, ask me. It's pretty bad. See if you remember, like the the derivative of cosecant u, negative cosecant u, cotan u. Remember the negative? Oh yeah. Well, that's why I gave you the formulas with you, just to reinforce, we always have to use the chain rule when we take the derivative. If it's not just x, you're going to have to multiply by the derivative of the argument. One in, I say like maybe 2% to 5% chance. Well, the one you want to know, I wouldn't worry about the inverse secant. That's not going to happen. But the inverse sine derivative and the inverse tan, I would know. Watch the inverse secant shows up. Then I'm going to have to go back and erase this recording. Inverse sine, inverse tan? Well, they're both just u prime over. They both have a 1 and a u squared. Yeah, tan, it has the plus. It's like the t in tan. What? I would, yeah. U prime over the absolute value of u times the square root of u squared minus 1. And for the inverse cosecant of u, it's just negative u prime over the absolute value of u square root of u squared minus 1. They're on top. Instead of writing it next to it, you can always just put it on top of the fraction. Right? It's always there. We always use the chain rule. Did anyone remember the derivative of the log base b of u? You did? Get out of town. Uh-huh. In the proper place. You got it? So it's just remember, so it's still u prime over u. It's just u invites his friend over in the denominator, the ln of b. So, okay, we ready to talk about antiderivatives? It's so exciting. I wish I could take this with you guys. It'd be so fun. Like, what are they going to do, right? 48 hours after the test. But it usually turns into more like 3 days by the time they get it. Is anyone having trouble? Anyone need to see anything else? Yeah, that one I had to, I made a mistake. So you make 7 sine u. Because I put cosine u twice and yeah, make 7 sine u. The antiderivative side. You have 2 columns, but I thought it would look too crazy up here. In the formula? No, like, because we always put it on the other side if there's one. The other side. Right. We made it a sine u. As long as you have du, it's all good. E to the u is easy. Right? Try to make it all good. Gasp. That was horrible. The one thing I wanted to point out with this, when you're going this way, I think people get confused when to say du and when to say du dx or u prime. You know, like when you take derivatives, if you take the derivative of some function of u, we apply the chain rule, right? It's f prime of u times du dx. That's the old chain rule. So when you go backwards, when you take the antiderivative, so the integral in the dx here with respect to x, when you integrate that, what happens is the dx up there cancels. So even though you need this du dx to go backwards, you're not going to see that in the formula, right? You're just going to see that. But so the antiderivative of f prime of u du equals f of u plus c. But you can't integrate any function of u without the derivative of the inside there, right? So even though we say, do you realize, okay, that means you have to have the derivative there to go work it backwards. So you take the derivative, you say du dx. When you take the antiderivative, it's du. So that's what you'll say. All right, you ready to go over these? Just pull them in. What's the antiderivative of 0? See, it's just a constant. The derivative of any constant is 0. What's the derivative of k with respect to u? Ku plus c. If that was a dx, it'd be kx. If it was a dt, it'd be kt. Okay, what is the antiderivative of u to the n? Yeah. Okay. Do you want over the n plus one? Or you could have the 1 over n plus 1 up front. Is that what you had? You had this? I'm going with what you say. Yeah. Is it plus what? Right? Sometimes we put it out front. But you always add 1 first to the exponent, then you multiply by the reciprocal of the new exponent. So yes. Yep. Antiderivative of cosine u, as long as you have du. This is only good if you have the du. Right? Sine u plus c. Secant u. Tan u, sorry. Secant u plus c. Secant squared u du. You're welcome. Right? Is secant squared u du. Oh, whoops. Double mistake. What is it? Negative cosine u du. Oh, what did I do? I don't know what I did. Okay. What's the next one? Next one? Okay, that's the first column. How we doing? Yeah? Yeah? A little fuzzy? Okay, here's a good one. Now, sometimes you see it as du over u, or you can see it as 1 over u du. Doesn't matter. ln, the absolute value of u plus c. Yes. Guys, you have to write the ln of the absolute value of u. The only time we can forget about it is if you're solving a differential equation in the free response. You write it the first time and then just forget about it. Okay? I just want to reinforce that. Okay? So when you integrate du over u, you get the ln of the absolute value of u. But if you're solving a differential equation, you don't have to justify, oh, it's positive, so I'll drop them. Just, you can drop them in that case. The free response question. All right, what's the next one? Let's see. So yeah, when you integrate a constant to some exponent, you write the constant to that exponent, but you divide by the ln. The base. What's the antiderivative of e to the u as long as you have du? With this k here, it's a constant. What can you do? Blow it out, and then so what do you get? K times f. You go to integrate a sum or a difference. What are you allowed to do? Separate them. So what would you get? Nice. Which one is this one? And this one. Like, these are the two you want to really... I think these are the... I just think it's annoying. I just don't think it shows up much. I mean, I could be wrong. Yeah, what do I know? I'm just teaching over here. What's this one? It's inverse tan. And you gave it away. I can't see. Oh, there it is. This one is the inverse secant of the absolute value of u plus c. But that one really doesn't show up. Okay. So those are like all the basic formulas you have to know. Differentiation formulas and integration formulas. Okay so far? Maybe that was fun? Good. Okay. So I was also asked to just go over e to the x and ln of x because sometimes you don't have a calculator. And remember, if it's a free response question and you have like the ln of e squared, you have to simplify it? No. But if it's a multiple choice question, they're going to simplify it. So you have to know it. So the first thing that you want to know is, and I have it on here, what these two graphs look like. Y equals the ln of x. You want to know, the domain is positives. I didn't write that on there. You can only take the log of a positive number. And it crosses here at 1. Its inverse is y equals e to the x. So like when x is 0, y is 1. It goes to the point 0, 1. Like that. So they're inverse functions. And because they're inverse functions, whatever one does, the other undoes. So whenever you have the composition of the two, you get out what you put in. So whenever you see the ln of e to the something, you get the something. When you have e to the ln of something, you get the something. As long as they're together, what one does, the other undoes. Okay, so let's simplify a little bit with these. So what is the ln of e? 1, because that's the ln of e to the first, so that's 1. What's the ln of 1 over e? Negative 1, because that's the ln of e to the negative 1. What's the ln of e squared? 2, right? Here's your happy face, right there. Oh, this one I didn't write the ln of e to the something. It's going to be 0, because isn't 1 e to the 0? So the ln of e to the 0 is 0. Or you can think of your ln graph and just remember, when x is 1, y is 0. What's the ln of 1 over e squared? Negative 2, because that's the ln of e to the negative 2. Now let's go the other way. We'll go ln function into the exponential function. What is e to the ln of 1? E to the ln of 8. E to the ln of sine x. Oh, now I can switch it. What's e to the first? E. Anything to the first is itself. And what about e to the 0? 1. You guys got that. Should I do this? I got it. Now, the reason I brought that up, because sometimes, and you might have seen with some of those AP problems with a weird day, you get a derivative and you don't have a calculator, and it might have to do with the ln of x, right? So, let's say you have to find the extrema. So you got to find critical values. You want to make a sign chart. So you have critical values when the derivative is either 0 or undefined. Well, tell me what value of x makes this undefined? 0. Really? You said you're going to sleep later, not now. That's good. It was good. Very fast. Okay, so 0 makes the denominator 0, so it makes it undefined. What value of x makes the derivative equal 0? Makes the numerator 0. 1. So my critical values would be 0 and 1. So you'd go to your sign chart, and you only want to mark it off at 0 and 1. Now, I'm going to put 0 all the way at this end, which I normally don't do. So I know why I'm not even going to bother testing to the left of 0. Can't take the ln of a negative, right? Very nice. Now, here's the reason I brought this up today. So we always have to take test values and plug them into the derivative. That might scare you. You might think, I don't know how to take the ln of numbers in my head. Well, you don't have to choose integers. If you have to take an ln of a number, make that number e to the something. Can you give me a number greater than 1 that's e to the something? E squared? I like it. So if we plug e squared into our derivative, what is the numerator equal to? 2. That's positive. And what about the denominator, positive or negative? So it's a positive over a positive. It's positive. Now what if you had to come up with a number between 0 and 1 and plug it in? E to the 1/2. Is that going to be less than 1 though? Square root of no, that's going to be greater than 1. E to the what? E to the negative 1. 1 over e. Ah, that was smart. Right? So do you want me to write 1 over e or e to the negative 1? Oh, jeez. Right. Same thing. I'm going to write them both. What? Just doing 2 different numbers? Nope. Okay, same thing. So now let's figure out if that's going to be positive or negative. Negative, because the ln of e to the negative 1 is negative, and then e to the negative 1 itself is positive. Right? E to anything is positive. Remember that. E to anything is always positive. Right? Think of that graph of y equals e to the x. It's always above that x-axis, even though I didn't really draw it that great. E to anything's always positive, right? So that would make the derivative negative in here. So what do I got for an extrema? Max or min? You better read left to right on this test. Okay. Now, you say you've got a relative min. Oh, I forgot I did that thesis. But please, guys, don't read, I know you've shown that the derivative is going from negative to positive, but you have to actually write that's relative min because f prime changes from negative to positive. And what word are we not allowed to say? Do you remember? It. That's the bad word. You have to identify what's changing. What are we talking about? Okay. So, okay, and then I had one more. Yeah, I can do it. I just wanted, with this whole exponential and logarithmic talk, just to practice taking derivatives of both. This is the derivative of the ln of u. So what's the derivative of ln of 2x going to equal? Well, what's the u? Because that goes downstairs. Okay, what's its derivative? That goes upstairs. So we could simplify it to 1 over x, right? U over u. U prime over u. Okay, what about the next one? You want the derivative of the ln of sine of 2x. What goes downstairs? Let's put that first. I always like doing the u down there first. Alright, it's derivative. Beautiful. So that's that rule, right? Derivative of ln of u is u prime over u. Now we got the derivative of e to the u. You got to know that's e to the u times u prime. What are we going to get for this? Derivative of e to the 2x. 2e to the 2x. That's e to the 2x times 2. What's the derivative of e to the cosine x? Negative sine x times e to the cosine x. E to the u times u prime. That's derivatives. Let's talk antiderivatives. Yeah, Moni wanted that. Here we go. All right. So this is little quickie u subs, right? Think about what would you need to make this a du over u. Come on, you can do this. Sydney, I'm calling on you for number 1. Let's try this one. Okay. Don't show her, she'll never learn. She gets mad if you try to show her stuff. Man. You got it? All right. You just got it in time. With less than 24 hours to go, she finally gets you sub. Yeah, your u is what's down here. So you you would need a 6 up here and a 1/6 out here. This is a 1/6 the integral of du over u. 1/6 the ln absolute value of 3x squared minus 6. Think about the next one. I know you know. I'm looking for someone who needs breakthrough. It actually does. Are you fried? All right. Woo! She even had like the head bob, and I know what I'm doing in this class. All right. You don't know? How about this one? Wait. No, it's all good. It's good to go. That's a big hint. Correct. What are you missing? Okay. Let's have someone else who's frightened. I want the frightened kids to volunteer. Oh, who can tell me this one? Jacqueline, that's true. She's like the most confident person. We never. Oh. Jacqueline, do you want to answer it? Or do you want Riley to answer it? It's one of you. Okay. She's thinking of you. Riley, what do you got? Okay. You got it. Oh, you didn't even have to put a constant in. Du is there. This already is du over u. Woo! Okay, and just a little u sub quickies with that e to the u du rule, right? You can integrate e to the u as long as you have du. If you've got it, you get e to the u. I have the rule on yours. I remind you above it, but I don't like doing it here. Okay, so I bet you could do this one in your head. Think about what you need. What are you going to have on the outside? Cameron's asking this one. All right, yep. Oh, he's got to get all fancy. E to the 7x, he said over 7. Let's see. It's just 1 second. He just 1 second. You need a 7, right? This e to the u, you need du. So you need a 1/7 on the outside. So if you have 1/7 e to the 7x, that's the same thing. Because you can't integrate e to the u without having du, which means the derivative of u. The derivative of 7x is 7. So it has to be there before you can say what the antiderivative is. Jillian, you feeling it? You went through a whole AP test. You coming into calc. Can you do a little u sub? Come on. Woo! That's good. Oh yeah. Woo! That's good. Now, because, right, if you want to integrate e to the u, you have to have the derivative of that. 8x. So you need a 1e. Yes. You gonna try the next one already? I love it. Wait, you going right for the answer? I gotta know which pen to use. You going for oh my gosh. Oh my gosh. She's actually right, but people you just scared a lot of people with that one. All right, because your u is cotan of 2x. What's the derivative of cotan of 2x? Yeah, it's negative cosecant squared of 2x times 2. So you're missing a negative 2. You put the 2 here. I just don't have enough room. So that's why you need a negative 1/2 on the outside. Fun. your eyes. And we can just take 2 seconds. Little cameras on your shoulder, like tilt toward the question. Guys, one more here. If you, here's the derivative. I did all those, right? Yeah. Okay, what the derivative critical values when the numerator or the denominator is 0. What value makes numerator 0? What value makes the denominator 0? You know before when I said repeat something, you'll get that? E to the x is always... Say it again, Jared. It's always positive. So is it ever 0? No! No, so we have one critical value. E to the x is always positive. I know! I didn't ask you if it exists. I said, what is it? Because you just believed it exists because I said it like that. That's what I did. I do. All right, then the rest I think you could get. The denominator is always positive. It always exists. Yeah. So the derivative always exists. Okay, left is negative. So we got what kind again? I'm in. I'm not going to write the whole reasoning again, but because f prime of x goes from negative to positive. Right? I'm going to just go to the highlights. Yes. Yes. Okay. So tomorrow, you know you're allowed just to go to cafeteria B when you come in the morning, and you don't have to go to first period this year. And then, then they'll call you into the library when they're ready for you. So I'll be down there, and you'll have something to eat and drink, and it'll be nice. What's that? No, don't be stressed. Yeah, be stressed. That's good. Okay, so I think you guys are pretty good understanding the format of this exam, like how it's broken up. I know you're going to get a break in here after the first 55 minutes, so you want to bring like a drink or some snacks or something with you. Don't think you're going to have time to go to Dunkin' Donuts. You won't. Like 15, 20 minutes. As far as the break in here, I don't think too much. That's what the kids are telling me. So we'll see. But this I didn't put on yours. Everyone knows if you can get a 3 or higher, that's good, right? Remember, there's no penalty for wrong multiple choice answers, so make sure you fill in every single guess. Don't let the time run out. I would bring a watch if you have one, so you don't have to like look around for the clock, so you can kind of keep an eye. Yeah, as long as you don't say, oh, it. Okay, that would have been bad. You are allowed in the free response, after you do your 2 calculator questions, they give you a half an hour. That's in a green insert. Not that that matters, but when you're working on the non-calculator free response, you can go back to that green booklet and fill in answers just without a calculator. That's what this is saying. Make sure you show your work, you know that. Oh yeah, here's a big thing. If you can't answer part A, but you need the answer to part A to answer part B or whatever, do something reasonable. As long as you use that wrong answer correctly, you're not going to lose points on the next parts. So don't lose point. Yeah. So if you. Yeah. Read through this. Okay. I put down like the big mistakes and what the real things are. And I'll be here for last minute. Yeah. Go home, sleep, and eat. And you can ask any last minute questions. Ask me tomorrow, and I'll be here for an hour today or so. Yes.